Hello guys! Today I'm going to be showing you how to calculate an empirical formula given a mass percentage. Now I know that some of you guys are going to be like, why do I even have to learn this stuff? Well, I'm going to tell you. Let's say you're taking a test and you studied all the subjects pretty hard, except the empirical formulas, which happen to be 5% of that test. So hypothetically speaking, if you had studied those empirical formulas, you could have gotten a 90%, but no, instead you get an 85. And not only that, but when you get your report card back, you realize that something is wrong. That test brought down your GPA by a fraction of a percentage. Frustrating, isn't it? Meanwhile, that other guy who until now had the same grade as you is ahead of you because he made the right choice of studying those empirical formulas. And now you apply to your dream college. But guess who also applies there? That's right, the other guy. Both of you guys barely qualify and the college has only one more space available, so they must make a decision. And because colleges love bigger numbers, guess who they pick? The other guy, because he studied his empirical formulas. Duh. And you get that letter back from the college and now your dreams are ruined. The more you look at that letter, the angrier you get. Blinded by anger and frustration, you make the choice of joining the dark side. Along with Darth Vader, you pursue his twisted plans, which include kidnapping puppies and hunting polar bears. Do you want to be a puppy kidnapper and a polar bear hunter? Oh, hell no! But don't worry, I got your back. Just pay attention to this video and you won't be hunting polar bears anytime soon. Alright, so moving on. An empirical formula is the smallest whole number ratio of atoms in a molecule. So this is often confused with a molecular formula, which is the actual number of atoms in a molecule. So for example, a molecule of ethylene, which is C2H4, would have 2 carbons and 4 hydrogens. So that's the molecular formula. So if you notice, 2 and 4 are both divisible by 2, which is the greatest common factor. So if we were to divide both of these numbers by their greatest common factor, or we simplify this ratio, we get the empirical formula. So if we divide the 2 carbons by 2, then we get 1 carbon. And we have 4 hydrogens, so divide that by 2, and you get 2 hydrogens. And so now we can write the empirical formula, which is CH2. So just make sure you know the difference between the molecular formula and the empirical formula, because they do sound similar and they look similar. But for this lesson, we're going to be focusing on the empirical formula. Alright, so in this problem, you can see that the masses are given to us in percentages. So our first step is going to be to convert these percentages to grams. So assuming that there are 100 total grams of this substance, you'd get 75 grams of carbon and 25 grams of hydrogen. So one way to think of this is 75% is equal to 0.75, so 0.75 times 100 is 75, and 25% is 0.25, so 0.25 times 100 is 25. And now the next step is to find the number of moles that you get from this amount of grams. So in order to do that, you take the grams and divide it by the molar mass. So heading on over to our periodic table, we see hydrogen is 1.0079 and carbon is 12.011 grams. So I'm going to write it over here on the side. So carbon was 12.011, remember grams per mole is the units, and 1.0079. And now it's time to convert these grams to moles. So for carbon, it's going to be 75 grams divided by the molar mass, which was 12.011 grams per mole. And as you can see, the grams units cancel out, and so you just be left with 75 divided by 12.011, which, if you do in your calculator, is 6.244. And the moles didn't cancel out, and so it's going to be left over at the end. So at the end, you have 6.244 moles. Now we do the same thing for hydrogen. So moles of hydrogen will be equal to 25 grams divided by 1.0079. And so same thing as before, grams cancel. You're left with 25 divided by 1.0079, which is 24.804 moles. So I decided to write it on a new page because we ran out of room. So anyways, the next step is to divide by the smallest value that we have here. In this case, it is clearly 6.244, which is carbon, as it is smaller than 24.804. The reason for this is because we're going to be setting carbon equal to 1, and then from there we will be able to see how many hydrogens there are for one carbon. So now we're going to set carbon equal to 1 by basically taking its value and dividing by the smallest value, which is itself. And so anything divided by itself is 1. And for hydrogen, we're going to do 24.804 divided by the smallest value, which is, again, 6.244. And that's going to be equal to, if you do that in your calculator, 3.972. And that's approximately equal to 4. And so now we have one carbon and we have 4 hydrogens. And so basically we're done now. Now you can just write the empirical formula, which is CH4. And there you go. That's the empirical formula. One more thing I forgot to mention. Sometimes these problems don't always come out with clean numbers like they did in the first problem. So here's a real quick example of this. I'm just going to fast forward through this problem because I'm tired. And so it's basically, it starts off the same as the previous problem did. It just changes a little bit at the end. So here's the part I wanted to show you. This is the part where you're dividing the moles of the substance by the smallest value to find that ratio. So as you can see, the oxygen ends up as a decimal, and it is a bit too far off to round to 1. So what do? Well, if you know your decimals, 1.33 is basically the same as 1 1/3 or 4/3. So, but we want the answer to be in whole numbers, so we want to get rid of the fraction by multiplying by the denominator, which in this case is 3. Make sure you multiply both the iron and the oxygen by 3 because you want to keep the ratio constant. Now you can see we have 3 irons and 4 oxygen, and so we're basically done. Just write out the empirical formula and that's that. Well guys, it's 1:30 a.m. right now. I'm extremely tired. I don't know if you guys noticed, but my enthusiasm has declined quite a bit. I hope you guys enjoyed this tutorial. I'll admit the beginning was really weird. I have no idea what I was doing, but a little too late to change that now. So, I'm out. Peace.